January 17, 1945. The Ardennes Forest, Belgium. The morning air cut like steel through the snow-laden pines, each breath visible in crystalline puffs, as Obergefreiter. Klaus Brenner adjusted his black Panzer beret and peered. Through the commander's cupola of his Tiger Y, the massive 57-ton beast beneath him rumbled with the confidence of German engineering. 8 inches of frontal armor. An 80-meter gun that could pierce any Allied tank at 2 kilometers. Around him, the forest echoed with the deep, guttural roar of dozens of tigers and panthers, their tracks grinding against frozen earth, their crews singing the old Panzer songs that had carried them from Poland to the gates of Moscow. The sound of metal against metal filled the crisp morning air, the distinctive clatter of tank tracks on frozen ground. A mechanical symphony that had announced German dominance across 3 continents. Each Tiger represented 6 months of precision manufacturing at the Henschel Works in Kassel, hand-fitted armor plates welded by master craftsmen, and the finest optical equipment Carl Zeiss could produce. These were not merely weapons. They were monuments to German industrial supremacy, rolling fortresses that embodied the Reich's unshakable belief in its technological and cultural superiority over the mechanized hordes of democracy. Brenner had heard the reports from the intelligence officers the night before, delivered with the casual confidence that had characterized German military briefings since the lightning victories of 1940. American Sherman tanks, thousands of them, were rolling through the Belgian countryside like a mechanical flood, their crews hastily trained, their machines hastily built. Their tactics reflecting the crude improvisation that German doctrine attributed to democratic warfare. The German tank crews had actually laughed, slapping their knees and sharing stories they'd heard from the Afrika Korps veterans who had returned from Tunisia with tales of American incompetence. Ronsons, they called them, cigarette lighters that burst into flames with the first hit. Tommy Cookers, the British had nicknamed them after watching so many burn on the desert sands of North Africa. The names had become part of Panzer folklore, repeated in every training manual, every tactical briefing, every casual conversation between crews who had grown comfortable with their mathematical superiority. How could these tin cans, these mechanical jokes produced by a nation that valued quantity over quality, possibly threaten the magnificent Tigers that had terrorized Soviet T-34s from Kursk to Königsberg and reduced British Churchills to smoking scrap from Normandy to the Rhine? The mockery ran deeper than mere professional disdain. It was cultural, ideological, woven into the very fabric of German military identity through 3 years of victories that had seemed to prove the fundamental superiority of German methods. German thinking, German civilization itself. For decades, German engineering had represented the pinnacle of precision, craftsmanship, and technological innovation. From the Mercedes-Benz racing cars that had dominated European circuits to the Junkers aircraft that had pioneered commercial aviation, from the Zeiss optics that had revolutionized photography to the Krupp steel that had built the world's most advanced battleships. The Tiger tank embodied this philosophy of excellence through precision, each one hand-assembled by skilled craftsmen who had learned their trades through the rigorous apprenticeship system that had made German manufacturing the envy of the world. Every component was fitted with tolerances measured in hundredths of millimeters, every weld inspected by master metalworkers whose families had been crafting steel for generations, every gun barrel rifled with mathematical precision that could place an 88mm round through a target the size of a dinner plate at ranges exceeding 2 kilometers. These machines were not merely weapons, they were expressions of German genius, rolling proof that superior culture produced superior technology, that the methodical precision of German thinking could overcome any challenge posed by the chaotic improvisation of democratic societies. Each Tiger that rolled off the production line carried with it the accumulated wisdom of German engineering, the perfected doctrines of German military science, the unshakable confidence of a civilization that had convinced itself of its own superiority. The mythology of German tank superiority was built on mathematics that seemed unassailable, numbers that had been verified in combat across every theater of war. A single Tiger I commanded by Hauptmann Johannes Bölter had destroyed 139 Soviet tanks on the Eastern Front before being knocked out near Kursk. At Villers-Bocage in June 1944, SS Obersturmführer Michael Wittmann had annihilated an entire British armored column, 14 tanks, and 15 armored vehicles in a matter of minutes, his lone Tiger moving through the Norman village like a mechanical reaper harvesting steel instead of grain. The tactical reports were clear and consistent. Tiger tanks routinely achieved kill ratios of 5-1, sometimes 10-1, against Allied armor. German after-action reports from Tunisia read like shooting gallery tallies. 47 American tanks destroyed for the loss of 3 German machines. 23 British tanks eliminated without a single German casualty. The mathematical reality seemed clear and immutable. 1 Tiger equaled 5 Shermans, perhaps more when factoring in crew training and tactical doctrine. German tank crews carried this equation into battle like a talisman, a mathematical proof of their inherent superiority that had been validated across 3 years of combat. The numbers had become part of German military culture, repeated in training manuals, cited in tactical briefings, incorporated into the operational planning that assumed German technological supremacy as a given constant in all strategic calculations. American tank doctrine, as understood by German intelligence through captured documents and prisoner interrogations, seemed to confirm their worst stereotypes about democratic warfare. The Americans, they believed, compensated for inferior quality with overwhelming quantity, the very antithesis of German military philosophy that emphasized the decisive impact of superior weapons operated by highly trained specialists. Where German panzer crews trained for months to master the sophisticated fire control systems and mechanical complexities of their Tigers, Americans allegedly rushed barely trained boys into simple, disposable tanks with the expectation that numerical superiority would eventually overwhelm German precision. Where German factories produced masterpieces of engineering like the Tiger, with its complex transmission systems and precision-manufactured components, American assembly lines churned out thousands of identical, mediocre machines using mass production techniques that prioritized speed over quality. It was, in the German military mind, a perfect metaphor for the fundamental weakness of democratic societies. They could produce vast quantities of inferior goods, but they could not achieve the excellence that came from combining superior culture with superior methods. The Sherman M4, introduced in 1942 and encountered first by German forces in North Africa, had indeed earned its grim nicknames through bitter experience. With only 76 millimeters of frontal armor, less than half the protection of a Tiger, and originally armed with a short-barreled 75 mm gun, firing low-velocity rounds that could barely penetrate German armor at combat ranges, early Shermans were systematically outmatched by virtually every German tank they encountered. German combat reports from Tunisia and Sicily read like technical demonstrations rather than battle accounts. Obergefreiter Hans Müller, commanding a Panzer IV in the 10th Panzer Division, recorded destroying 7 American tanks in a single engagement near Kasserine Pass, his 75 mm gun penetrating Sherman armor at ranges exceeding 1,500 meters, while American rounds bounced harmlessly off his frontal armor. Similar reports flooded back from every engagement. American tanks burning in neat rows, their crews abandoning their machines before engaging, their formations dissolving under the methodical fire of German gunnery that had been perfected through years of training and combat experience. The mathematical reality seemed clear and scientifically verifiable. 1 Tiger equaled 5 Shermans, 1 Panther equaled 3 Shermans, Even the older Panzerbarfuß maintained favorable exchange ratios against American armor. German tank crews carried these calculations into combat like gospel truth, mathematical validation of everything the Reich claimed about the superiority of German culture and German science. The sound of the 80-80 mm gun had become the acoustic signature of German dominance, a sharp, authoritative crack that announced the destruction of another Allied tank with the precision of a scientific experiment. German crews knew that sound intimately, had heard it echo across the steppes of Russia, where it had silenced hundreds of T-34s, across the deserts of North Africa, where it had reduced British armor to burning scrap, across the hedgerows of Normandy, where it had stopped American advances in their tracks. Each shot was a statement, each hit a validation of German superiority, each destroyed enemy tank a confirmation that precision engineering and superior training could overcome any numerical disadvantage. The sound carried with it the weight of German confidence, the acoustic proof that culture and civilization would always triumph over crude industrial production and democratic improvisation. But mathematics, as Brenner would soon discover, told only part of the story. The sound that would shatter his world that morning would be different, deeper, more resonant, carrying with it the weight of a transformation that German intelligence had completely failed to perceive and German doctrine had dismissed as impossible. The American industrial machine that German intelligence had dismissed as quantity over quality was, in reality, undergoing a revolutionary transformation that had no parallel in military history. In the factories of Detroit, where assembly lines had once produced Buicks and Chevrolets for a civilian market that consumed automobiles like no society in human history, engineers were quietly perfecting something the Germans had never anticipated: the ability to rapidly evolve and improve their designs while maintaining mass production at scales that dwarfed anything achieved by European industry. The Sherman that had burned so easily in North Africa during the first encounters with German armor was not the same machine. Rolling through the Ardennes in January 1945. Between 1942 and 1945, American industry had produced not just 49,234 Sherman tanks, more than the total tank production of Germany, Britain, and the Soviet Union combined, but had continuously refined every aspect of their design based on systematic analysis of battlefield feedback from 3 theaters of war. This was not the crude quantity over quality approach of German propaganda, but something far more sophisticated and ultimately more deadly: the systematic application of American industrial capacity and intellectual resources to the problems of armored warfare through methods that combined mass production with continuous innovation. American engineers had created something that German military doctrine had declared impossible: weapons that could be produced in unlimited quantities while simultaneously improving in quality and effectiveness. The transformation had begun systematically in the summer of 1943, when American metallurgists at the Watertown Arsenal in Massachusetts, working with captured German 80-mm rounds and detailed analysis of battle damage from Tunisia, realized that the fundamental problem was not the Sherman's armor thickness, but its composition, geometry, and the mathematical relationships between angle of impact and penetration resistance. Using techniques borrowed from American skyscraper construction, where engineers had learned to maximize structural strength while minimizing material weight, and automotive manufacturing methods that had been perfected through decades of mass production, they began producing tanks with sloped, welded armor plates that could deflect hits that would have penetrated earlier models. The mathematical principles were complex, involving trigonometric calculations that determined armor effectiveness increased exponentially with angle of impact. But American engineers had solved the equations and translated them into production modifications that could be implemented across thousands of tanks without disrupting manufacturing schedules. More critically, They had solved the gun problem through systematic research that combined captured German technology with American manufacturing capabilities. The 76-meter M1 gun, the weapon that would shatter German confidence like crystal, represented everything the Wehrmacht had failed to understand about American industrial philosophy and everything German intelligence had underestimated about American engineering capability. While German engineers pursued perfection through complexity, creating the magnificent but mechanically troubled 80 dB that required specialized ammunition, extensive maintenance, and components that were increasingly difficult to manufacture under wartime conditions, American engineers pursued effectiveness through reliability and adaptability. The 76mm gun was simpler than its German counterpart in design, faster to produce using American mass production techniques, easier to maintain in field conditions using standard tools and replacement parts, and when loaded with the new M93 armor-piercing round, capable of penetrating 150 millimeters of armor at 500 meters, more than enough to punch through the side armor of any German tank ever produced. The round itself was a marvel of American metallurgy that combined captured German tungsten carbide technology with American mass production methods. Each projectile represented the culmination of 3 years of continuous research and development conducted simultaneously at Aberdeen Proving Ground in Maryland, the Watertown Arsenal in Massachusetts, and university laboratories across the United States where academic researchers collaborated with military engineers, without the ideological constraints that had crippled German scientific research. Every M93 round was manufactured to tolerances that German industry, struggling with material shortages, bombing attacks, and the disruption of supply chains, could no longer achieve consistently. The tungsten carbide cores were produced using techniques developed through cooperation between American university metallurgy departments and industrial research laboratories, refined through thousands of test firings that measured penetration, performance against every type of German armor, under controlled scientific conditions. But the 76mm gun was merely the most visible aspect of a larger transformation that had revolutionized every aspect of American tank warfare. American tank crews were now fighting with radios in every tank, not just command vehicles, allowing for coordination and tactical flexibility that German commanders, accustomed to fighting with limited radio equipment and rigid tactical doctrines, could barely comprehend. They were supported by dedicated tank destroyers like the M36, with its 90mm gun that could penetrate any German armor at combat ranges, mobile artillery systems that could deliver precise fires within minutes of being called through sophisticated fire control networks that connected every level of command, and close air support from P-47 Thunderbolts and P-51 Mustangs, equipped with rockets and bombs specifically designed for anti-armor work. Most importantly, they were operating within tactical doctrines that had evolved continuously throughout the war, incorporating lessons learned from every engagement, every defeat, every victory into systematic improvements that were disseminated throughout the entire American tank force through training programs that emphasized adaptability and innovation rather than rigid adherence to predetermined tactics. The sound came first on that crystalline morning, not the sharp crack of the legendary 80 dB that German crews knew so well, but a deeper, more resonant boom that seemed to roll across the frozen landscape like thunder from a different kind of storm. The acoustic signature was fundamentally different, carrying harmonics that spoke of larger powder charges, heavier projectiles, and barrel pressures that German gun designers had considered impossible to achieve in field conditions. Brenner, scanning the tree line through his commander's periscope, with the confident routine of a veteran who had survived 3 years of armored combat, felt his blood freeze as he watched the muzzle flash bloom orange against the white snow. The flash was larger and more sustained than any gun flash he had ever seen, burning with an intensity that suggested propellant charges far exceeding anything in German ammunition stocks. The round struck the Tiger to his left, with a sound like a massive hammer hitting an anvil. But the impact was followed by something no German tank crew had experienced before: the distinctive whistle of a tungsten carbide penetrator continuing through armor plate with mathematical precision. Through his periscope, Brenner watched in stunned disbelief as the projectile punched clean through both the side armor and the internal bulkhead, the entry hole glowing cherry red for just a moment before the entire tank erupted in flames that burned with the white-hot intensity of magnesium igniting in pure oxygen. Unmöglich, he whispered into his throat microphone. Impossible. The mathematics of German superiority, the careful calculations that had sustained Wehrmacht confidence for 3 years, the scientific certainty that had made German tank crews feel invincible, crumbled in that single terrible moment. The sound of that gun was not just different, it was revolutionary, announcing the arrival of technology that German intelligence had dismissed as impossible for American industry to achieve, and German doctrine had declared incompatible with mass production methods. What Brenner could not see, could not understand from his position in the forest as his carefully ordered world began to collapse around him, was the larger transformation that his moment of shock represented. The Sherman tanks emerging from the morning mist were not the crude, disposable machines of German propaganda, but the products of an industrial and intellectual revolution that had taken place in American factories, research laboratories, testing grounds, and training centers across 3 years of total war. At the Aberdeen Proving Ground in Maryland, American engineers had built complete replicas of Tiger and Panther tanks, studying every rivet, every weld, every millimeter of armor thickness with scientific precision that exceeded anything achieved by German intelligence services. They had fired thousands of rounds at captured German armor, measuring penetration angles with instruments that could detect variations of hundredths of degrees, studying metallurgy at the molecular level using electron microscopes, perfecting their understanding of how different steel compositions behaved under extreme stress through methods that combined German scientific knowledge with American industrial capability. They had interviewed hundreds of Sherman crews who had survived tank-versus-tank combat, systematically analyzing every engagement, every tactical situation, every equipment failure, incorporating every lesson into evolving designs through feedback loops that connected battlefield experience directly to factory production lines. This was not the crude trial-and-error process that German propaganda attributed to American industry, but systematic scientific method applied to warfare with resources and organizational capacity that no previous military force in history had possessed. The American approach to tank warfare was not, as German intelligence had assumed, simply throwing numbers at a problem until quantity overwhelmed quality. It was something far more sophisticated and ultimately more deadly: the systematic application of scientific method to the problems of armored combat, combined with industrial capacity that could translate theoretical improvements into practical weapons faster than German forces could adapt their tactics to counter them, while German panzer crews clung to the tactics and technologies that had brought them victory in 1940. Fighting the war of 1945 with the methods of 1939, American tank doctrine was evolving at the speed of war itself, driven by organizational structures that encouraged innovation and adaptation rather than rigid adherence to predetermined doctrine. American tank crews were fighting with an entirely different philosophy of warfare, one that emphasized continuous learning and improvement over traditional notions of military discipline and hierarchical command. The 76mm gun that was now tearing through German armor with mathematical precision represented only the most visible aspect of this transformation. Each round was manufactured using quality control methods that German industry, devastated by strategic bombing and starved of raw materials, could no longer achieve consistently. The tungsten carbide cores were produced using techniques that had been perfected through cooperation between American universities and private industry, combining academic research with practical engineering in ways that the increasingly centralized and secretive German war economy could not match American. Tank crews were fighting with tactical doctrines that had been developed through systematic analysis of combat performance, incorporating lessons learned from engagements in North Africa, Italy, and Normandy into training programs that emphasized flexibility and adaptation. Where German doctrine emphasized the technical superiority of individual weapon systems operated by highly trained specialists, American doctrine emphasized the integration of combined arms operations that multiplied the effectiveness of individual components through coordinated action. The Shermans advancing through the Ardennes were not fighting alone, but as part of integrated battle groups that included mobile artillery systems capable of delivering precise fires within minutes of being requested, tank destroyers armed with guns that could penetrate any German armor at combat ranges, infantry equipped with bazookas and other anti-tank weapons that had been specifically designed to defeat German armor, and close air support that could deliver devastating attacks with accuracy that had been impossible earlier in the war. Most critically, they were backed by a logistics system that represented perhaps the greatest American achievement of the war, a supply network of such complexity and efficiency that German military leaders had initially dismissed reports of its capabilities as Allied propaganda. The tanks rolling through Belgian forests in January 1945 were supported by supply lines that stretched back through the ports of Antwerp and Cherbourg to factories in Detroit, connecting battlefield consumption directly to production. Schedules through organizational methods that had been perfected by American corporations during decades of peacetime. Competition. The second round struck. Brenner's own Tiger in the turret ring, the junction where the rotating turret met the tank's hull, a target area barely 6 inches wide that required incredible precision to hit at combat ranges while both vehicles were moving across uneven terrain. The fact that an American gunner could achieve such accuracy spoke to improvements in fire control systems, optical equipment, and crew training that German intelligence had completely failed to detect. The impact sent a shockwave through the entire 57-ton machine, and Brenner felt his world tilt sideways as the precision machinery that controlled turret rotation jammed, trapping him and his crew in their steel coffin. The sound of that second impact was different from the first, not the clean penetration of side armor, but the complex cacophony of a tungsten carbide round ricocheting through the turret basket, destroying optical equipment worth thousands of Reichsmarks and precision machinery that had taken months to manufacture and could no longer be replaced. Through the smoke and chaos that filled his fighting compartment, Brenner could hear his radio operators screaming that the engine was on fire, that they needed to abandon the tank immediately. But the words seemed to come from a great distance, filtered through the shock of discovering that everything he had believed about German technological superiority was not just wrong, but catastrophically and dangerously wrong. The sound of that American gun had shattered more than armor plate. It had shattered the mathematical certainties that had sustained German confidence, the cultural assumptions that had made German crews feel invincible, the ideological beliefs that had convinced an entire military establishment that superior culture would inevitably produce superior technology. In that moment of impact, Brenner experienced not just physical defeat, but intellectual collapse, the sudden realization that the war he thought he was fighting was not the war that was actually happening. As Brenner struggled to open his commander's hatch, fighting against the bent metal and his own disbelief, he caught his first clear glimpse of the enemy that had destroyed his invincible Tiger. Through the smoke and snow, through the optical distortion caused by heat rising from burning German armor, he could see them clearly now. Not the crude, hastily built machines he had expected, but sleek, purposeful-looking tanks moving with a coordination and confidence that spoke of extensive, training and battlefield experience that German intelligence had insisted Americans lacked. Their guns were already traversing toward the next target, their movements smooth and mechanical, like a deadly dance choreographed by some unseen intelligence that coordinated their actions with mathematical precision. The sound of their engines was different too, deeper, more powerful, suggesting mechanical improvements that made them faster and more reliable than the temperamental Tigers that required hours of maintenance for every hour of operation and broke down with increasing frequency as replacement parts became scarce. These were not the desperate, undertrained crews of Nazi propaganda, hastily thrown into combat after minimal preparation, but professional soldiers operating machines that had been designed, tested, and perfected through 3 years of continuous warfare. Their movements suggested tactical training that emphasized coordination and mutual support rather than individual heroics, mechanical reliability that allowed them to operate for extended periods without maintenance, and confidence that came from knowing they were backed by industrial and logistical resources that could replace any losses. The Americans advancing through the Ardennes forest represented something that German military doctrine had declared theoretically impossible: the marriage of quantity and quality, mass production and continuous improvement, democratic flexibility and military effectiveness. They were the products of a society that could simultaneously wage global war on 3 continents while maintaining the scientific and industrial infrastructure necessary to continuously upgrade and improve their weapons based on systematic analysis of battlefield performance. This was not the crude, industrial mobilization that German propaganda had attributed to American war production, but something far more sophisticated: the systematic application of scientific method to military problems, combined with organizational structures that could translate theoretical improvements into practical weapons faster than any previous military force in history had achieved. American industry had not simply outproduced German industry, it had out-innovated it, creating weapon systems that improved continuously rather than remaining static. Tactical doctrines that evolved based on experience rather than rigid adherence to predetermined plans. The 70-cm gun that had just destroyed Brenner's Tiger was emblematic of this larger transformation, but it was far from the only manifestation of American technological and organizational superiority. Unlike the German 88mm, which represented the pinnacle of 1940 technology, but had changed little since its introduction due to the Reich's increasingly desperate resource situation and the disruption of research and development programs by strategic bombing. The American gun was part of a weapon system that had evolved continuously throughout the war. American tanks in 1945 bore little resemblance to the machines that had first landed in North Africa in 1942, not because they had been completely redesigned, which would have disrupted production schedules, but because every component had been systematically improved based on mathematical analysis of battlefield performance, scientific study of captured German equipment, and systematic incorporation of lessons learned from thousands of combat engagements. American armor protection had evolved from simple steel plates welded together, with basic techniques to sophisticated combinations of metals and angles designed through mathematical modeling that calculated optimal protection to weight ratios using computational methods that German industry could no longer support. The sloped frontal armor of the latest Sherman variants was actually more effective than the nominally thicker flat armor of early Tiger tanks, despite weighing less, because American engineers had solved the geometric equations that German designers had ignored in favor of brute force approaches that consumed increasingly scarce materials. American optics, initially inferior to German equipment that had represented the world's finest precision manufacturing, had been improved through systematic reverse engineering of captured German scopes, incorporating the best features into mass-produced American systems that were actually superior to their German originals because they could be manufactured to tighter tolerances using American precision machinery that had not been disrupted by bombing attacks. American gun sights could now achieve accuracy that exceeded German equipment while being produced in quantities that made them available to every tank crew rather than reserved for elite units. American ammunition had progressed from standard armor-piercing rounds that could barely penetrate German armor at combat ranges to sophisticated projectiles designed specifically to defeat German armor at typical engagement distances. Each round represented the culmination of thousands of hours of ballistics research conducted at university laboratories, materials science performed by industrial research departments, and field testing that measured performance under actual combat conditions rather than theoretical calculations. Most critically, American tank tactics had evolved from the crude frontal assaults of 1942, which had indeed resulted in the heavy losses that German propaganda had gleefully documented to sophisticated, combined arms operations that maximized the Shermans' strengths while minimizing its weaknesses through systematic application of lessons learned from every theater of war. Satupuedi tanks now advancing through the Ardennes were not fighting according to the predictable patterns that German intelligence had catalogued and German doctrine had prepared to counter, but were employing constantly evolving tactics that incorporated innovations developed through systematic analysis of combat performance. They were backed by intelligence systems that provided real-time information about German positions through radio networks that connected every level of command. Supply systems that could deliver ammunition and fuel to the front lines faster than German forces could retreat or reposition, and medical systems that could evacuate wounded crews and return them to combat within days rather than weeks. This systematic approach to warfare, the ability to identify problems through scientific analysis, develop solutions through systematic research and development, test them under controlled conditions that simulated combat stress, and implement improvements across thousands of machines and hundreds of thousands of soldiers, represented something genuinely new in military history. It was not just American industrial capacity that was winning the war, but American intellectual capacity, the ability to think systematically about complex problems, organize resources efficiently to address them, and adapt solutions faster than enemies could develop countermeasures. As Brenner finally succeeded in opening his commander's hatch and stumbled from his burning Tiger, leaving behind the sophisticated machinery that had represented the pinnacle of German engineering achievement, he carried with him not just the physical shock of defeat, but the intellectual shock of discovering that everything he had been taught about American military capability was fundamentally and catastrophically wrong. The crude, mass-produced machines of German propaganda had revealed themselves to be sophisticated weapons systems operated by well-trained, professional soldiers backed by the most advanced military-industrial complex in human history. The hasty improvisation that German doctrine had attributed to democratic warfare had proven to be systematic. Scientific method applied to military problems with resources and organizational capability that no authoritarian system had ever achieved. The sound that had announced his defeat, the deep boom of the 76mm gun, would echo in his memory for the rest of his life, not just as the sound of his tank being destroyed, but as the sound of an entire worldview collapsing under the weight of empirical evidence. The mathematical certainty of German superiority, the cultural confidence in European technological supremacy, the ideological belief that democratic societies could not match the focused efficiency of authoritarian systems, all of it crumbled in the face of that single, devastating round that had punched through armor that German science had calculated to be impenetrable. The Americans who captured Brenner and his surviving crew members 3 hours later were not the crude barbarians of Nazi propaganda, but professional soldiers who treated their prisoners with a courtesy and efficiency that spoke of extensive training in International law and clear doctrine regarding prisoner treatment that had been developed through systematic study of military ethics and practical considerations of prisoner management. They provided immediate medical attention to wounded Germans using medical supplies that seemed almost luxurious compared to the increasingly scarce bandages, morphine, and antibiotics that had sustained German forces for months as supply lines collapsed under the weight of strategic bombing and tactical defeat. American medics worked with equipment and pharmaceuticals that represented the most advanced medical technology available anywhere in the world, products of research and development programs that had continued to operate even under wartime conditions. They shared their rations with hungry prisoners, K-rations that contained not just adequate nutrition calculated to sustain soldiers under combat conditions, but luxuries like cigarettes, chocolate, coffee, and processed foods that most German soldiers had not tasted in years as the Reich's food distribution system collapsed under the strain of total war. Each meal represented not just superior logistics, but a superior economic system that could simultaneously wage global war and maintain living standards that exceeded European peacetime norms. The casual way American soldiers treated these provisions, their assumption that anything consumed would be quickly replaced through supply systems that connected battlefield consumption to factory production with mathematical precision, spoke of productive capacity so vast that it made German industrial achievements seem almost primitive by comparison. American soldiers discarded partially eaten meals that would have represented luxury to German forces, threw away cigarettes that German soldiers would have carefully saved and rationed, used equipment worth hundreds of dollars as disposable items that could be replaced without concern. The cigarettes the American soldiers offered, real tobacco from Virginia and North Carolina, not the mixture of leaves, sawdust, paper, and ersatz materials. The German soldiers had been smoking for 2 years as tobacco. Imports ceased and domestic production was diverted to other uses, became a symbol of American abundance that haunted every German soldier who experienced it. Each cigarette represented industrial capacity that could treat luxury items as disposable commodities, an economy so productive that it could simultaneously equip armies on 3 continents and maintain civilian living standards that exceeded European peacetime levels. But perhaps most devastating of all was the gradual realization that these Americans were not fighting for conquest or national glory, but for abstract ideas, concepts like freedom, democracy, and individual rights that seemed to motivate them more effectively than any amount of propaganda or ideological indoctrination could achieve. They spoke casually of going home to lives and opportunities that most German soldiers could barely comprehend, of a society where individual achievement was possible and encouraged, where prosperity was not a zero-sum game to be won through conquest, but a condition that could be created through cooperation, innovation, and systematic application of human resources. They carried photographs of homes that looked like palaces to European standards, spoke of automobiles owned by common workers, described educational opportunities available to anyone with the intelligence and determination to pursue them. Their casual confidence came not from ideological fanaticism, but from the secure knowledge that they were fighting to preserve a way of life that was demonstrably superior to any alternative, a social and economic system that had proven its effectiveness through measurable improvements in living standards, technological capability, and individual opportunity. The transformation of American military capability between 1942 and 1945 represented more than just technological and tactical evolution. It represented the full mobilization of democratic society for war through methods that had no parallel in human history. The 76-meter gun that had destroyed Brenner's Tiger was not just the product of American factories, but of American universities where scientists and engineers collaborated on ballistics research without the ideological constraints that had crippled German science, American testing facilities where new designs were evaluated through rigorous empirical methods rather than political considerations. American training centers where crews learned to operate their machines with maximum effectiveness through systematic instruction that emphasized problem-solving rather than blind obedience. The tank crews advancing through the Ardennes were not just soldiers, but citizen soldiers who brought to their military service the problem-solving skills and innovative thinking that characterized American society. They were mechanics who could repair their machines under fire using improvised techniques developed through experience and shared through training programs. Engineers who could adapt their tactics to terrain and weather conditions without waiting for orders from higher command. Leaders who could coordinate complex operations through radio networks that connected every level of command from individual tanks to Army headquarters. This flexibility and adaptability, dismissed by German military doctrine as lack of discipline and proper military spirit, proved to be one of America's greatest military advantages in the rapidly changing conditions of modern warfare. While German forces fought with the precision and efficiency of a well-oiled machine, following doctrine that had been perfected in peacetime exercises but could not adapt to changing conditions. American forces fought with the creativity and resilience of a living organism, capable of learning from experience and evolving solutions to new challenges faster than their enemies could develop countermeasures. The systematic methods that American forces brought to warfare represented something genuinely revolutionary in military affairs. 30 years, application of scientific method to tactical problems. The integration of civilian industrial and intellectual resources with military requirements. The creation of organizational structures that could continuously improve performance while maintaining operational